Hello everyone. Today let us see one more numerical which was asked in JEE Mains of 2025. This is from chapter 1, that is electric charges and fields, and the problem goes like this. The problem is an electron is made to enter symmetrically between two parallel and equally but oppositely charged metal plates, each of 10 centimeter length. The electron emerges out of the field region with a horizontal component of velocity 10 to the power of 6 meters per second. If the magnitude of the electric field between the plates is 9.1 volt per centimeter, then the vertical component of the velocity of electron is, and then they have given four options. So in those four options, option 1 is 1 into 10 to the power of 6 meters per second, second is 0, third is 16 into 10 to the power of 6 meters per second, and the fourth one is 16 into 10 to the power of 4 meters per second. So this is the problem. For that, additional data what they have given is, that is mass of electron is 9.1 into 10 to the power of minus 31 kg, and charge of electron is 1.6 into 10 to the power of minus 19 coulombs. This is the data what they have given. And now our duty is to find out the vertical component of velocity of the electron when it comes out. So this is the figure. So here you can clearly see this is one plate and this is the other plate. So now if you can see, so we can assume one plate is positively charged. So naturally, as the electron is a negatively charged particle, so it moves naturally towards the positive plate. So we can think this as the positive plate and we can think this as the negative plate. This is the electron. From here it started, and this is when it is starting, its horizontal component of velocity is Vx. As it is attracted towards the positive plate, it goes towards the positive plate. And if you can see, Vx, that is which I have shown here with the green color, this one is the horizontal component of velocity, and Vy is the vertical component of velocity. What they have asked is Vy is a question mark. That is the thing what they have asked. When it comes out, what is Vy? So they have given each plate has a length of 10 centimeters. The given data is each plate has a length of 10 centimeters, that is, and then what they have given is they have given the electric field between the plates, that is 9.1 volt per centimeter, and mass of the electron and charge of the electron, we know them by heart, even if they don't give, we know them, and horizontal component of velocity 10 to the power of 6 meters per second. This is what all the given data what they have given. And then now we need to find the vertical component of velocity. Okay, let us first consider the horizontal motion, because they have given the horizontal velocity. And we know very well velocity is equal to distance by time. Therefore, time is equal to distance by velocity. In the horizontal component, distance is 10 centimeters. That is 10 into 10 to the power of minus 2 meters divided by this one, that is horizontal component of velocity, which is 10 to the power of 6 meters per second. When it comes up, it becomes 10 to the power of minus 6. Then altogether 10 to the power of minus 2 minus 6, it becomes minus 8 plus 1. It is 10 to the power of minus 7 seconds. This is the time taken. Now we want vertical component of velocity. So for that you can see Vy is Uy, you can write Uy plus Ayt, that is vertical component of final velocity is equal to initial component of the vertical component plus acceleration in the vertical component multiplied by time. So initially there is no vertical component, so it is 0, and Ay acceleration is E by m into time 10 to the power of minus 7 seconds. And how it is E by m, I have shown here in the bracket. You can see here in the bracket. We know F is equal to ma, okay, and A is equal to F by m, force by mass, and force is equal to charge of the electron into electric field. We all know from first chapter that is a relationship between electric field and force. E is equal to F by Q. Therefore, F is equal to Q into E. We know that. So that is, I have substituted here. That is, in the case of electron, instead of Q, we are writing E here. And now you know all the values. Substitute them, you will get Vy. Therefore, Vy is equal to, I have already substituted here to save the time. That is, you know the formula what we got. That is E by m into T. That is, T means 10 to the power of minus 7. E means charge of the electron, which is 1.6 into 10 to the power of minus 19. Capital E, that is electric field, 9.1 into 10 to the power of 2, 10 square. Why? It is volt per centimeter they have given. So, when the centimeter is 10 to the power of minus 2, which comes to the numerator, it is 10 to the power of plus 2. And time is 10 to the power of minus 7, which we got earlier. And m is the mass of the electron, which is 9.1 into 10 to the power of minus 31 kg. And substituted all the values. So once we have substituted all these values and once we simplify, it's very easy. Calculation part is too easy because 9.1 and 9.1 will get cancelled, and what all you have to do is the powers of 10. So 1.6 as it is we can take 10 to the power of minus 19 plus 2 minus 7, and when this 31 comes up it becomes plus 31, and totally plus 31 plus 2 becomes plus 33, and negative powers minus 19 minus 7, which is 26. So totally it becomes 10 to the power of 7. But in the options they did not give 1.6. So if you want to see the options, I'll take you up. These are the options. In these options they have given 10 to the power of 6 with 1. So that cannot be the answer. 0, no, it's not the answer. 16 into 10 to the power of 6. They did not give 1.6. So we need to convert that 1.6 to 16, and then we will get, this is the one, that is 16 into 10 to the power of 6 meters per second. So this is an option 3. So the answer is 16 into 10 to the power of 6, that is, it is 16 into 10 to the power of 6 meters per second. That is option number 3. Thanks for watching. We'll meet in the next video with one more numerical. God bless you all.